Scipy stands for scientific Python. Okay, it's called scientific Python because you can do it. It has packages, sub packages for performing scientific operations. Like, can talk about integration, differentiation using your signal processing. Okay, so all this advanced concept. It does not come, you know, with default installation. You need to install it in your root directory. So how do you install in your root directory? You have to go. So if I run this, okay, you see this is where Python is installed, right? So I need to go to this location. Okay, so this is how we're going to install packages. Okay, I think this is the first package you're going to install, right? So we say here cmd. Okay, go to the location where you have Python installed. Okay, so this is where Python is installed. How do I know? Because when you run PyCharm, you get this path. Okay, now here you can say pip install, okay, Scipy. Okay, so I already have it installed. Okay, so it says all requirement already satisfied. Okay, when you're using a new machine, okay, it may
Sir, we
not
are
be
not
there.
able to see the screen, only Python.
Oh, okay, hold on. Can you see this?
Yeah, no comment from
Yes. So this is what I typed. Pip pip install Scipy. Okay, pip install Scipy will install Scipy. Okay, now in my case, I already have Scipy installed. Okay, so it says requirement already satisfied. In your case, when you are doing it for the first time, okay, it will download from internet and install it. So it needs to be connected to your internet. It needs to be connected to your internet. Okay, and how does it connect? It connects to what is called as PyPy. Okay, Python index. Okay, on python.org, there's something called as PyPy, PYPI. Okay, so you have those are Python indexes. Okay, so the Python team, okay, will shortlist popular index. Let's say you write an index. Sorry, you write a module or package. Okay, you write a module. What is module? Module is collection of functions, and package is collection of your different files that you have. Okay, so let's say you wrote packages. So packages can have multiple modules. Okay, modules will have functions, and your packages will have multiple modules. Okay, modules can have functions and classes both. Okay, so you put them together, and then the team will evaluate and they add to the pipeline. Now, when they add to the pipeline, it becomes much easy to install. If you just say, okay, you say pip install scipy, and it's going to install it. Okay, so it knows where to connect, which version is right for your Python, and based on that, it will get those installer done, right? Okay, that's why you need to be connected to internet to do pip install. So if you don't do it, and if you try to import scipy, you will get error. Okay, you will get that scipy not found. So you have to install it. Okay, fine. Now one of the important aspect, okay, for us in using scipy is to perform permutation and combination. Okay, what is permutation and what is combination? We'll see how to solve permutation combination here. So what is permutation and combination? Come on, speak, guys. You know it, right? It's okay if you get it wrong.
I don't remember it well. I just remember something like n factorial for like something rather than that. I don't remember. It's part of problem.
Okay. Whatever you remember.
Number of ways permutation.
Okay. So what is the similarity? Okay. Permutation and combination. Okay. So what is similarity between both? Similarity is both of them are about choosing R things from N things. Okay. So I need to choose 5 people from given 10 people. I need to choose 5 fruits from 10 fruits. I need to choose 3 blue color balls and 3 red color balls from 5 blue color balls and 10 red color balls. So it is about, yes.
Sorry to interrupt you, but we can't, like your screen is not visible.
Yeah, I'm not sharing anything.
Okay, all
Okay,
right.
just
I thought
yeah. First understand, then I'm going to share it. Okay, focus on what
yeah,
I'm
sorry.
saying. Okay, so yeah, sure. So I'm saying that your permutation and combination both are about choosing R things from N things. Okay, so you have 5 red color balls and you want to choose 3 red color balls. You have 3 right, 5 red color, 5 blue color balls, and you want to choose 3 red color and 3 white color. Right. So of course N will be greater than R. Right. So okay, that's the common. Okay. Permutation is about where order matters and combination is where order doesn't matter. Okay. Now let me write it. Okay. So both are about choosing R things from given N things. Okay. In both the cases, there's one more similarity. Both the cases, okay, replacement is not allowed in by default. Okay, you can have a separate case. So default case is replacement is not allowed. So that means you have to say the replacement is allowed. That means if I say choose 3 things from 5, I can take 1. Then again I put it back and again I take same one. Again I put it back, again I take same one. Right? So by default that is not allowed. Okay? That's the similarity. Difference is permutation. Permutation. Order is, okay, order is important. In which order you get is important. Okay, combination is where order is not important. So this is how I remember. Okay, I remember O for order, right? So order O is closer to P or to C? P, right? So closer, the order is closer to P. That's why order is allowed in permutation. Okay, this is how I remember. Okay, bad way, but yeah, to remember. Okay, now you tell me. Okay, so if the problem is similar, same problem. Okay, which one will have a higher value? Permutation will have a higher value, or combination will be a higher value? Why it's taking so much time to think? Okay, so if I have to choose A and B, if I have to choose A and B, okay, so one way is to select AB, second way is to select BA, right, and AB. Now, out of these two, which is permutation, which is combination problem? How do you select two things from two things? How do you select two things from two things? So, to select two things from two things, okay, you can select AB, and then you can select, in the second case, you can select AB and BA. Which is permutation, which is combination?
Combination is BA, sir.
There are two things, right? Two different statement. Which is permutation solution, which is combination solution?
Combination solution is
Combination, I'm saying order is not important. When I say order is not important, that means AB is same as BA. When order is not important, order is not important. So this is your combination. Order is not important. So whether I say A, B or BA, it's the same meaning. Permutation order is important, right? Whether you say AB or BA, they are different. Okay. Now tell me which one has more value. Which will give you more value? Where order is important, that will give you more value, no?
a permutation.
Yes.
Permutation.
Okay. Because, okay, in combination, whether you write A, B, C, D, E, or you write A, D, C, B, E, or you say E, D, C, B, A, all means same in which one? They all mean same in which one?
Permutation.
Combination, yeah. Order is not important.
Combination.
So it doesn't
Hmm.
matter which way you put. Which way
Okay.
you put, it doesn't matter. Order doesn't matter. So it is a combination. You're combining things. Permutation is where these three are different, three different values. Always your number of combinations that you get from a same data will be less than the number of permutations that you get. Number of combination will always be less than the permutation. Okay. Okay. So how do you calculate? So this is the formula. Okay. Let's start with combination, or let's start with permutation first. Okay. Let's start with permutation. Permutation is n factorial by n minus r factorial. Okay. N factorial by n minus r factorial. Okay. Forget about it. Okay. Let me ask you this way. Okay. So let's say we have something like this, and we have another one like this. N factorial by n minus r factorial, okay, and then r factorial. Okay. Think and tell me which one is for combination, which is for permutation.
Permutation is first one and combination is second one, sir. Hello? Hello?
Yes, what did you say?
Permutation is first one, sir, and combination is second one.
Permutation is first one. Why?
No, but I remember the formula, sir.
Less dividend. I mean,
Yes. So see, among these two, which will give us less value? Among these two, which will give you less value?
second one.
Second one, you're dividing, no.
Yeah.
If this is 100, you're dividing 100 by something 2, 3, 4. This difference. If this is 100, this will be less than 100 because you're dividing by another number. So this will be higher and this will be lower. Okay. So permutation will be this because this is giving a higher value, right? And this is giving us a lower value. So this will go for combination.
Combination.
Okay. So if you remember this, that permutation order is important, combination order is not important, then it's easy to remember. Okay. Not that it's going to impact our knowledge on data science or analytics. Okay. Okay. You don't have to remember, but just I'm saying you. Okay. These are something that you have done it before. So that's why. Okay. So this is the formula. Now, if I ask you a question, okay, in a group of 6 boys and 4 girls, okay, so we have 6 boys and 4 girls, okay, I need to form a committee with 4 members. I need to form a committee with 4 members, okay, and condition is there has to be a boy, at least a boy in the committee. Now, is this a permutation problem or combination problem?
It's combination because we don't want a boy only in the first place or anything. It can
No,
be
no, no,
anywhere.
no, no, no. It's not about boy only. Okay. Whoever you select, combination, it's a combination problem. Okay. So whoever you select, so it's not about boy or girl, right? Now let's say if we 4 are part of this committee, right? So whether I take my first name or I take your first, I take your as first name, doesn't matter. 4 members, if they say, right, when you talk about 11 players that is playing in the team today, right? Doesn't matter whose name you take first. Correct or not? Okay. Who are the
Yeah.
4 members in the committee? These 4 members. Now, who doesn't matter. It doesn't change if I take my name first, then if I take your name first, you can become second team. No, it's the same team, right?
Mm.
So here, order of the members doesn't matter. Whose name is first on the paper or whose name is last on the paper doesn't matter. We 4 are part of the committee, so we 4, will preside over the committee, right? So it doesn't matter what's our name on the paper, right? So that's why order doesn't matter. So we talk about order and combinations, right? Make sense? Okay. Okay. So this is the basic thing. Now we'll solve using Scipy. So this is a combination problem, right? So I'm going to say from Scipy dot special. So special sub package has libraries for combination and permutation. I'm going to say, okay, import combination, comma, perm is for permutation. Okay. Now, okay, now when we said, okay, 4 members, right? So what are the possible values? Possible values are you select 3 boys and 1 girl. correct? You select 2 boys and 2 girls. You select
One
1
boy
boy,
and 3 girls.
3
Three
girls,
girls.
and you select all 4 boys, right? All 4 girls is not
It's not
valid.
mandatory.
Yeah, no. It's not valid. Okay, we
Yeah,
want
at
at
least
least
one
one
boy should-
member. Okay, so these are the possible combinations. Now,
Okay.
if you find, so I'm asking you how many possibilities, right? So, you know, if you find, okay, let's say this is X, okay, this is X, or let's say X1, this is X2, and this is X3, and this is say X4. So total you get is, total combination is X1 plus X1 X1 plus X2 plus X3 plus X4. Yes or no? So this is how you get total combinations. Now let's see how to solve using our combination thing. So I'm going to say sum equal to 0. Okay. And we'll find sum. First we'll find the combination for first, then we'll add, then combination of second, we will add, and so on, right? So first case is 3 boys and 1 girl. So it give you, so it's like count, okay, equal to combination of 6 boys. Okay, so there are n is 6, so it is n comma r combination. So 6 boys, and out of which I need 3 boys. Okay, multiplied by combination 4 girls, and I need 1 girl from the 4 girls. Okay, so this will be added to sum. Okay, now how many times I need to copy? 1, 2, 3, 4 times, right? 3 times more. Okay, now this is 3 out of 6. Okay, I need 2 out of 6. I need 1 out of 6. I need 4 out of 6. Here 1 out of 4, 2 out of 4, 3 out of 4, and 0 out of 4. 0, sorry. 0 out of 4. So now total combination is combination possible is sum. Is it running the same P2? Yes. It is 209 combinations. Okay, so you'll end up getting 209 combination. If repetition is allowed, they have parameter called repetition here. Okay, so repetition means repetition is allowed, and repetition, if repetition is allowed, then you will say comma repetition equal to true. Repetition equal to true. But I told you by default repetition is false, so you can say false. You get 209 combinations. Okay, any questions so far on this? No, right? Okay. In the notes I'll share, you can see how to how to calculate manually also. Okay, so this is your combination. Permutation now. Okay. Now let's say there are, okay, there are three people, okay, and it's rainy season, so you have four coats, okay, five waistcoats, and let's say six caps, rain caps. Okay, and you have three members in the house. Okay, what are different combinations of wearing this? Now, is this a permutation or combination problem? This becomes a permutation
Permutation.
problem, okay, because you cannot wear coats as waistcoats, right? So you will be taking from here, and from here separately. Okay, so here, if you take, let's say, a coat and a waistcoat and a caps, it's one combination. Now, if you change A to B in waist, so A, B, A will be a different combination, right? Now, if I take B here, A here, and A here, it's different combination. You see what I'm saying? So let's say coats are A, B, C, D. You have A, B, C, D, four coats. You have A, B, C, D, E, five waist, or let's say L, M, N, O, P, right? And you have, six. So the moment I change, if I take first one from here, and first one from here, and first one from here, it's one combination. If I take first one, second one, first one, or I take second one, first one, they are different combinations. So it will turn out to be your permutation kind of problem. Okay. So in permutation, okay, you can have this. Okay. So we will, we do multiplication, right? So first you have to take 3 out of 4, right? So I'm going to say CNT equal to permutation 4, 3. Okay, 3 members, 4 coats, right? Then you have count 2, let's say we'll do 1 and 2, okay, equal to permutation of 5 and 3. CNT 3 will be your permutation of 6, 3. And to find total permutation, CNT1 into CNT2 into CNT3. Okay, so many combinations possible. Okay, with just this, you have so many combinations possible. Okay, one of the main application, okay, of Scipy comes into optimization problem. Okay, so Abhiram, you have optimization in your syllabus, right? You can solve optimization problem using Scipy. Okay, so we'll take one optimization problem and we'll see how it works. Okay, what does optimization mean? Okay, you have given problem, and given problem will have multiple solution. Okay, given problem will have multiple solution.
Yeah, the solution will be maximum or minimum.
Yeah, you want to find, okay, the most appropriate solution. What is best? Okay, what is the best solution? That's what we want to find in optimization. So optimization, so when you say best, best can be lowest or highest. So if you want, let's say if you want to produce product, so production of product, you want to do the maximum. So we call it as maximization of problem. Optimization means either it's a maximization or minimization problem. Maximization means you want to get more, as many as possible, right? If you like chocolate, you want to get as many chocolate as possible in your present. If you don't like chocolate, you want to get as minimum chocolate as possible in your present. Yes or no? So in a business, let's say, okay, you are manufacturing business, you want to produce as many goods as possible. Cost. If you talk about cost, you want to have as minimum cost as possible. See, if you want a cost, if you know there is, if you don't control, there is no end to the cost, right? You can maximize to maximize cost. There is no end. You can maximize. You can spend as much as you want, but that's not the thing. You want to minimize the spend. Okay, but is it possible to spend zero? No, because you have to spend in your food, in your travel, in your call and things like that, right? So business has to pay salary, has to pay rent, has to pay the electricity charges, marketing cost, and all those things, right? So they cannot make it zero. Okay, they want to make it as less as possible. We talk about profit. If you talk about profit, you talk about something that you want more, right? So okay, to get less, it's easy. You make only one product. Okay, you sell one, it's easy, you can sell it easily. But no, that's not the case. You want to maximize the product so that your sales will be maximized, so that your profit will be maximized. So when you say optimization, it is either a minimization problem or maximization problem. Okay, we'll take one simple example. Let's say there's a company. Okay, let me move this to another file. Okay, so let's take an example. So there is a company, okay, that makes laptops and desktops. That makes laptops and desktops. Okay. Now the profit that they make, okay, per laptop, okay, is, let's say, okay, I'll put it here itself. Profit is about 750 rupees. Okay, and for desktop it is about 1000 rupees. Okay, so company makes laptops and desktops, and the average is okay. Now every business has to operate under some constraint. Okay, if there is no constraint, what does it mean? It means you can sell any number of laptops, you can sell any number of desktops. There is no end of selling. That means, okay, you can make lakhs of computers, right? Why will you stop at making 1000 or 5000? If there's no limit, I mean, if you can produce whatever you can sell, right? If I get unlimited number of students for my class, I will do whole day training only. No, every batch I will do 100. It's not possible, right? So what happens is your business has to operate under some constraint. Constraint could be that space, constraint could be time, constraint could be the raw material, right? Okay, so let's look at the constraint. So okay, so this is called given problem. Okay, and what is your objective? So your optimization problem will always have one objective. So objective in this case, objective is to maximize profit. Okay, so now let's say if I can find out, okay, the best combination, not maximize desktop and maximize laptop separately. We have to maximize together, right? We have to find XY value or laptop and desktop value such that total, okay, together will be the maximum profit, right? So we say here, let's say we put X equal to number of laptops that we'll make. So the profit from laptop is going to be 750X, correct? And let's say if Y is the number of desktop you're going to make, right? So you get 1000X. That's your profit from laptop. And your objective here, okay, or actually solution, not objective, it's solution. Solution is 750X plus 1000X. This is the maximum profit. Minimum, there is not, when you can get zero or loss also you can get. Okay, what it says is you cannot get a profit more than this. Okay, this is your maximum profit. Okay, but how do we decide X and Y? So there it has to operate under some constraint. There's some constraint. So let's look at some constraint. Let's say, okay, so let's say you have first constraint, okay? Constraint 1. We'll try to solve using graph, we'll try to solve using Excel, and then we'll come to Python, okay? So today maybe we'll just use first 1 or 2 methods. So constraint equal to, okay, so what it says is they need processing chips. They need processing chips, okay? And total chips that are available is 10,000 chips only. Okay, total chips are available 10,000. You don't have access to more than 10,000 chips. Okay, and both of them requires 1 chip each. Okay, so what it means is your X is the number of laptop, right? And desktop is Y, correct? So it implies that X into 1 plus Y into 1 is less than equal to 10,000. So why do we say less than equal to? We are saying less than equal to because you can use less than 10,000 chips or equal to 10,000 chips, but you cannot use more than 10,000, isn't it? So if X is your, okay, if X is your number of laptops and Y is the number of desktops, since they uses ones, I'm going to say X into 1 plus Y into 1. Okay, so number of chips used will be same as X plus Y. And the total chips, okay, cannot be more than 10,000. That's what I'm saying, less than equal to. It is possible to use less than. Yes or no? Yes. So this is your first constraint. Second constraint, it says is, okay, memory chipset. Okay, so memory chipset comes in, let's say 1 GB. Okay, so chipset comes in 1 GB size. Okay, now we also see that laptops need 1 GB memory chipset, whereas desktops need 2 GB memory. So the combination that they make, okay, the configuration that they make, they need 2 GB, okay, memory chipset. Okay, laptop 1 GB is enough. So what is the second constraint? Tell me fast. This means implies, okay, not equal to greater than. I mean to say this is implies. Tell me fast. How do you write the constraint formula here? So you are making X laptops. X laptops need 1 memory chipset, right? So it is X plus Y is desktop. Desktop will need 2 memory cards. So 2 into X, which is 2 into Y, which is 2y. Okay. Now, how many memory cards we have? We have total of
10,000.
15,000. Okay. So this is okay processing chip. This is memory chip 15,000. So now you say x plus 2y is less than 15,000. The 15,000 is given to you. Okay. Now we also see that, okay, the time to assemble. Okay, time to assemble or time to make. Okay, one laptop is 4 minutes. Okay, and desktop is 3 minutes. Okay, time to assemble one laptop is 4 minutes. Time to assemble that one desktop is 3 minutes. And total time that is available. Okay, so you'll calculate based on number of shift, into number of days working, into number of labors that you have. Okay, is about 25,000 minutes available. Okay, so now tell me, how do we design this constraint? Fast. Come on.
4x plus 3y.
4x plus 3y has to be less than equal to 25,000, right?
25,000.
Because you cannot have more time. Okay, so these are your three constraints. Let's say these are three constraints and this is objective. Now we need to figure out what's the value of x and y. Okay, so okay, we'll see one with the graph. Okay, so to begin with, let's divide the data, everything by 1,000. Okay, so you get x plus y is less than equal to 10. Second constraint you get x plus 2y is less than equal to 15. Okay, and 4x plus 3y is less than equal to 25. Okay, now let's quickly, let me open Paint 1 second. Okay, and I'm going to draw our graph here. Okay, so let's say you have this is your y-axis, this is your x-axis, correct? First case we say x plus y, okay, equal to 10. Okay, x plus y equal to 10. Okay, so when x is 0, let's say we divide this like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, okay. So now let's say, okay. So first one is x plus y less than 10, right? X plus y less than 10. So if x is 0, y becomes 10. So when x is 0, y becomes 10, right? And when y is 0, x becomes 10. Okay. So this is how we draw our first line. And when we say less than means this area. Less than means this area. Okay. So all these are possible solutions. You cannot manufacture minus laptops, minus desktops. So we are not going to go to second, third, or fourth quadrant. We'll be staying in first quadrant. You can't have minus numbers, right? Now, second we say is x plus 2y equal to 15. So when x is 0, 2y is 15, that means y is 7.5. 9, 8, 7. 7, 8, 9, 10, right? This is 7. 7.5. Okay? So this is 7.5. And when you make y 0, then y becomes 15. 11, 12, 13, 14, 15. So this is your second constraint line. Okay. Third constraint we said 4x plus 3y equal to 25. So when you make y 0, x becomes 25 by 4, which is 12.5, 6.25. 12.5, 6.25, right? So this is 7. This is 6. Okay. So 6.25. And when x is 0, y becomes 25 by 3, 8 point something. So this is 10, 9, 8.1 or something here. So that means we have to draw from 6. When y equal to 6, is it? No. Sorry, I think I got it wrong. X equal to 6.5, right? Y is 0. 4x is 25. So 6 point here is going to be this one. Okay, so it's going to be 10, 9, 8, 7, 6. 6.25. And when x is 0, y is 8 point something. 8.3 something, right? So you have 7, 8. This is here. So now you need to draw a line from here till here. 7, 8, 9, 10. Yeah. Okay. So this becomes your feasible area. Okay. This is your feasible area. Okay. This is your feasible area. Okay. So possible values are, okay, this one, this is 1, 1, 1, and 1. So you have to calculate at each of these 4 points and see which gives you maximum profit. Obviously, profit here will be 0, right? 0x0y, profit will be 0 into 750 plus 0 into 1000. This will be 0, right? This will also be 0 here. Okay, not 0. Here your x is 0, right? Y is 7.25. So this becomes x0, no laptop, right? And desktop 7.25, right? Into, because we divided by 1000, we multiply by 1000. So 7,250. So 7,250 desktop and 0 laptops. This is around what? 3, 4, 5, 6, 6.125 something. Third option becomes 6,125, let's say. Laptops, no, this is desktops. X is notebook, laptops. Okay, and no desktop, 0 desktop. And then this point is, okay, approximately if you solve it, okay, if you see what is the x value, x is small, right? X is what? If you solve, you get x. Can you see? I'm going to draw a line from here. Okay. This is straight line, right? So this looks like 1.8 something, 1,800. So x-axis is laptop, 1,800 laptop plus this is 7,000. 7,000. Y is desktop. So calculate the profit and see which has the maximum profit. 4 possible values you got. Out of 4, whichever is the maximum, that is your solution. Okay, so we have solved using graph. This is using graph theory, right? Same thing tomorrow we'll solve using Excel and also using Scipy. Okay, we'll stop here for today. Okay, we'll connect and we'll verify if what we did is right or not. Okay.